Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sabrina bin Abdul Wahid. My matrix number P0920103667 and my team member is Muhammad Daniel Haikal bin Muhammad Razali and his matrix number was P0920108084 and Muhammad Izzat Najmi bin Mansur and his matrix number was P0920106065 and we will present the assignment of computer simulation, which is the question 5. So I will explain the problem description of this project. From this assignment, it was a simple design of shaft that made from steel that have young modulus of 205 gigapascal using ratio of 0.27 and yield strength as 250 megapascal. Based on the question given, the shaft fixed at point D and have two forces, which is Fa 6,000 pound and Fb 500 pound. So the problem is to define the principal stress, principal plane, and maximum stress at point H, maximum stress of the shaft, maximum displacement of the shaft, and lastly, safety of factor based on the factor applied. So to solve those problems, we use the ANSYS software.
Assalamualaikum, and my name is Muhammad Izzat Najmi bin Mansur. My matrix number is P0920100065. I will talk about the modeling, which include the geometry, element type, and material properties, meshing, and also boundary condition. For the geometry, first we choose the modeling, and then we put our coordinate. Where in this term, I put using the meters, and then we have the tree block. All the tree block will be glued using the Boolean glue technique. Next is the element type. First we choose the element type, and then we add the element type, and then we choose solid and choose brick 185, and it will appears like this. Next is the material properties. First we choose material props, and then we choose structural, linear, elastic, and isotropic. It will appears a table like this, and we put our young modulus value and also our Poisson ratio value. Next is the meshing. We choose the meshing and then mesh tool, and then it will appears a table like this. And this table we choose the shape, which is the hex shape, and then we set the line and put our value for our meshing that we already calculated, and the final result will be like this. Next is the boundary condition. First we choose the solution, and next is define loads. Next is apply. Next is structural. We choose force, moment, and nodes. So for first force, which is 2668.9393 Newton, the nodes number is 8485. And second, the force is 622.74 after we calculated, because the force given is including the angle. So the nodes number is 12,264. That's all from me.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel Haikal bin Muhammad Razali. My matric number is B0920100084. Now we explain about the theoretical value. So let's continue. The normal stress at point H is 2644 pound per inch squared. For the shear stress at point H is 2500 pound per inch squared. For the principal plane at point H, there are 2 degree angle, which is 31.1 degree and also 131.1 degree. For the principal stress at point H, for the 31.1 degree is 1506 pound per inch squared. Meanwhile, for 131.1 degree is negative 4150 pound per inch squared. For the maximum stress of the shaft is 2644 pound per inch squared, and the maximum displacement of the shaft is 0.012 inch. For the factor of safety is 0.273. Next is the experimental value. First, we can see that the overall shaft data and also the data at the point H. So, I will explain the detail on the data that we provided. For the shear stress at point H is 3.466 pound per inch squared. The principal stress at point H is for angle 31.1 degree is 7.191 pound per inch squared, and also at 131.1 degree is negative 2.724 pound per inch squared. For the maximum stress of shaft is 84266.926 pound per inch squared. For the maximum displacement of the shaft is 0.00078 inch. For the factor of safety is 0.43. Now I will explain on the comparison and the percentage error. As we can see that there are a huge difference in theoretical and experimental value, especially at point H. For example, for the shear stress at point H, that it is 250 pound per inch squared. Meanwhile, for the experimental value is 3.466 pound per inch squared. We can see that there are very huge amount of difference. Next is the maximum stress of the shaft, where overall of the shaft you can see that the theoretical value is 2644 pounds per inch squared. Meanwhile, for the experimental value is 84266.926 pounds per inch squared. Also show a huge difference of the stress value. Meanwhile, for the factor of safety, there are not too much of difference, where 0.273. Meanwhile, for the experimental value is 0.43. To show more on the detail on the differences on comparison, we can show it in form of percentage difference. So for the percentage difference of the shear stress at point H is 72029.26%. That is very huge. For the principal stress at point H at angle 31.1 degree is 20842.85%. Meanwhile, for 131.1 degree is 152249.49%. For the maximum stress of the shaft is 57.61%. For the maximum displacement of the shaft is 1424.75%. And the percentage difference for the factor of safety is 36.51. So, how can we reduce the percentage difference and increase the accuracy of the experimental value? So there are few ways to enhance the accuracy of the result, which are change the boundary condition, select the best element type selection, and also set the mesh refinement. That's all from me. Thank you.